Here's some remarks about crawling the web. So we already discussed the web as a graph. The nodes of the web are the web objects, which are pages and of various types, HTML, images, PDF, forms, videos, and so on. The nodes are hopefully always uniquely identified by URLs, although you can have multiple URLs referring to the same node. And the edges are the hyperlinks, which go from one page to another page. And the edges are uniquely identified by where they start and where they end. And so if you take a web crawling algorithm, it starts with a set of URLs which you want to crawl. It puts those URLs in a queue, and then it goes through this algorithm forever. And actually, when this algorithm finishes, it starts again because it wants to keep everything up to date. So it looks at the queue of URLs to visit, takes the first URL from the list, and it takes it out from the queue, marks it as having been taken, and goes off and tries to find it. And it finds the contents of whatever's at that URL, does whatever you want with it, it brings it back, the whole content. It then goes into your pipeline, which breaks it up into tokens and does the stemming and all that type of stuff. Then you mark that URL as being visited. You then look at the URL. One of the processing you did when you got here was to find all the hyperlinks that it has. Then you look at those hyperlinks and see whether or not it's been visited. And that's non-trivial because you presumably have a giant list of things being visited. Note all this is being done in parallel. You have lots of crawlers, because you can't do this with one crawler. So you have to make all your crawlers consistent and things like that. So this is a non-trivial parallel algorithm, but really pretty straightforward as parallel algorithms go. Because there's a basic parallelism. Every web page can be done independently, and it is. I don't think this you would expect to be a highly efficient parallel algorithm. It points out that if we're not going to do a crawler in this class, but it's a pretty simple thing to write, especially in Java, which is good at I/O. And of course, in the real world, Bing's and Google's crawlers are very complicated. They have to worry about redirections of encryption and passwords and databases and being polite and JavaScript and other scripting on the page, the various languages the page can be in, the fact that pages are changing and they're duplicated, and you need to make certain you visit a page often enough. And when that page is very important, like the White House page, you update it pretty often. If it's my page, you don't update it as much. And like I said, there are some parallelism issues to get load balancing and things like that. And you have to have enough disk space to store all this on.